Hey, we're going to look at activity 2 for week three's lab. I'm going to just kind of walk you through a little bit, and I'll share my screen here again and move this out of the way. Okay, so we're looking at activity 2 now. We've already done activity 1. With activity 2, you're going to measure a certain amount of water, 100 milliliters of pure water. Here, use maybe bottled water would work. You're going to put that in the calorimeter that you've just used for activity 1. You're going to stir it a little bit to make sure that the water is at a constant temperature before we begin. And that's because, maybe your calorimeter is warmer or cooler than your water. You just don't want any like changes happening before you start your experiments here. Um, and so you're going to go through a series of adding different amounts of a couple of different salts. So calcium chloride and ammonium chloride. And you're going to add each of those separately at different masses. And so you'll weigh out on your scale and your weigh dish. First, 5 grams of calcium chloride. You'll add it then to your calorimeter once your water temperature is stabilized. You'll stir the solution with your thermometer, and you're going to keep stirring until your temperature stops changing. So this is an exothermic reaction, so your temperature should go up. So energy should come out of these chemicals. And we would see that as a rise in temperature in the thermometer. You can dump this down the drain, rinse the cup out, the calorimeter cup out, dry it, place it back, and you're going to do it again for 10 grams of calcium chloride and then for 15 grams of calcium chloride. And then you'll do it for 5, 10, and 15 grams of ammonium chloride. So that ammonium chloride piece is activity 3. So it's really the same. And all of this information is going to go into this larger data table 2. So your masses of water, you're starting with 100 milliliters of water. Remember, it's 100 grams per mil for the density. So all across your very top column here, you should have 100 grams, 100 milliliters, 100 grams. The mass of your salt should be super close to 5 grams, 10 grams, 15, 5, 10, 15. Now it might not be right on. You might have 4.92 or something like that. Just record whatever you've got. It should be pretty close to 5, 10, and 15. And then we've got something called the moles of salt. So we're actually going to learn about molar mass in chapter 7. So I really wanted to take a chance to work through this with you, just as a preview and also to help you with today's lab. So let me pull up a whiteboard and share that really quick. Okay, so something that I don't expect you to know yet is how to calculate the molar mass. So I'm just going to give it to you. The molar mass of calcium chloride is 110.98 grams for every mole. Mole is kind of like a unit, like maybe dozen or pair. Like a dozen eggs is 12 eggs. A mole is a certain number of items of whatever chemical we're using. For right now, don't worry about that. You just need this value. That value from ammonium chloride, NH4Cl, is 53.491 grams per mole. And so if you're really interested in how these come about, we just go to our periodic table, which we'll introduce in a couple of weeks, and just add the grams per mole for all of these, calcium, chloride, nitrogen, hydrogen, chloride. But again, like I said, we'll get there in chapter 7. For right now, you just need to know these values. And so what I'm going to do is show you how to do the calculation for calcium chloride, and then you'll be able to do it for all the others. So in your very first column of this data table 2, it asks you for moles of salt. And so for our first trial, you have 5 grams of calcium chloride. That's should be what you measured, is really close to 5 grams of calcium chloride. And they're asking you for the moles, and they're saying grams times mole per gram. So what that means is 5 grams of calcium chloride, or maybe 4.99 grams, whatever you've measured out of calcium chloride, times this molar mass. So times 110 point. Let me actually fix that. Doing it backwards. Right out my conversion factor. There we go. I'm actually going to do it like this, times when I've got something like this where I have a fraction, I can flip those over one another. So I'm actually going to put 110 grams on the bottom, so that grams will cancel grams. And that is the mass of 1 mole of calcium chloride. So when I go, this should be 110.98. So I'll just go 5 divided by 110.98. And I know that this is a really roundabout way to doing it. I could have just told you to divide it, but that will help us out. It'll help us out when we get to chapter 7. So 5, a molar mass conversion. And I divide to get 0.0450. And this is the number of moles. If you put 5 grams of calcium chloride into your calorimeter, you put 0.0450 moles. So if you put 5 grams of this in, it's 0.045 moles. Now that's different for every chemical. So that was for 5 grams of calcium chloride. You do this with 10, you do this with 15. And then for ammonia chloride, you would do the same. 53.491 grams is the mass of 1 mole for ammonium chloride. And so I would divide this out and get 0.0935 moles. And so you can do that for 10 grams of ammonium chloride, for 15 grams of ammonium chloride, and divide it out, and you'll get different values there. And that's what you're putting in the third line of data table 2. So let me stop sharing this and go back. Okay, so that goes here in this line. So the initial temperature is your initial temperature before you put anything in. So for my data, that was 24 degrees Celsius. Okay, so back to the whiteboard. Oh, actually, hold on. Let's go back to this. Oh, sorry about that. So let's pull this back up again. And okay, we've got our final temperature, which is going to be when your temperature stops changing. And you're just going to record that down. The change in temperature is where you subtract the final minus the initial temperatures. So you should be able to do that column really easily. You're going to do the heat absorbed. And so we're using this 4.184 times 100 grams of water times whatever you got here. In my case, it was 7. So, let me see if I can clear that. So that is our heat times specific heat of water is 4.184 joules. And then we're going to use 100 grams of water. And then my difference in temperature when I did this was 7 degrees Celsius. And this is 4.184 joules per gram degrees Celsius. Okay, so when I multiply this out, it gives me 2,926. And if you look very closely at your data table, it tells you to take the negative, the inverse of this, or the negative value of this. So that is what you're going to be filling in there. Then it tells us the heat capacity. It asks us for the heat capacity. We calculated that in activity 1. In activity 1, I calculated mine to be 31.6. The next row asks us, I'll go back because it's maybe a little bit easier to look at back and forth here. The next row asks us to, look at the heat absorbed by the calorimeter. So this is looking at the heat capacity of the calorimeter. So in my case, from activity 1, I calculated 31.6 times 7. That was my temperature change. And so again, it's got a negative value in front of that. So when I multiply 31.6 times 7, I get 221.2, and I need the negative. Enthalpy of the solution is taking that value and adding it to Kw that we calculated up here with the heat absorbed. And so that was, for me, that was negative 2,926. And then the Kc that we just talked about was negative 221.2. And so when I add those together, I get negative 3147. Okay, working through this, I take that number for enthalpy of solution and I just divide it by 1,000, so 3.15. And then I'm going to take that value, so this will be 3.15, and I'm going to take this value here and divide it by the moles up here that we calculated out. So if you remember on the share screen, it was 0.045 moles. So I'm going to get negative 3.15, that's here, divided by 0.0450, and this should be about negative 70. And so you'll be able to do that for all of these. You're then asked to create a another spreadsheet using the mass of calcium chloride and the change in temperature So our masses are, of course, 5, 10, and 15 grams, or very close to it. And that should be in grams. And our changes in temperature are what we calculated off. So I had 7.0 and 14.0 and 21.0. Okay, so now again, I'm just going to go and highlight these. I'm going to insert a chart. I'm going to use a scatter plot here. It's going to give me a nice positive correlation. I'm going to rename this change in temp degree C versus mass. I'm going to click somewhere else and add chart element so I can label these axes. And mass of CaCl2 in grams. And the y-axis title is, oh shoot. Oh no. There we go. Deleted everything. I just hit the back button a bunch of times. This is change in temperature, and that is in degrees C. Again, I'm going to right click, or I'm going to click on one of my data points and then right click, add a trend line, and linear should be the one that pops up, and that's fine. I might ask you for your equation. You can do an r squared if you want. And that'll help you answer some of the questions. It doesn't ask you to do the exact same thing for your ammonium chloride as well. And you're going to use these graphs to look at the trends to be able to look at your data and to answer questions through 5. Number 5 looks at percent error. It gives you the actual enthalpy of a um, for calcium chloride. And it gives you this actual minus experimental divided by actual. So actual minus experimental times, so your experimental that you calculated would be up here. So you'll subtract that off and divide it by the actual that you're given here and multiply it by 100. So I hope that is helpful.